Okay, so what we've just seen is that if delta S squared is greater than 0, if the interval is greater than 0, then in general you can find a reference frame which is moving with velocity v, delta r over delta t, which is less than the speed of light. So with delta S squared is greater than 0, then there does exist a frame which moves with velocity less than the speed of light, in which the two events are simultaneous. And we call this, therefore, a time-like interval. So when delta S squared is greater than 0, we call these two events, the interval between those two events, a time-like interval. Okay, by the same logic, if delta S squared is less than 0, okay, so if the interval is less than 0, then that implies that c delta t squared is less than delta r squared. And again, if we rewrite it like this, that means that that there is now that in order for these two events to be simultaneous, you would have to boost to a reference frame which was moving at a velocity that's greater than the speed of light. Okay, and since that's not possible, that means that there is no proper time. There, in fact, is no reference frame in which the two events are simultaneous. Okay, and in this case, when delta S squared is less than 0, we call this a space-like interval. Okay, and so for space-like interval, there is no frame in which the two events are simultaneous, because again, when delta S squared is less than 0, that means that frame would have to be moving it faster than the speed of light, which is not possible. So there's no proper time. So whenever delta S squared is negative, there is no proper time. Okay, so just like we define the proper time when delta S squared is greater than 0, and the proper time only makes sense when delta S squared is greater than 0, we can, when delta S squared is less than 0, when it's negative, we can define the proper length, which is just, as shown here, it's the square root of the absolute value of the interval. And this is the distance between two events that happen at the same point in time. And so again, even if they don't happen at the same point in time in a particular reference frame, if delta S squared is less than 0, you can always find a reference frame in which they do happen, in which these two events do happen at the same point in time, and then delta S squared, the square root of delta S squared, the absolute value of delta S squared, gives you that actual proper length. Okay, the crossover between a time-like and a space-like interval is when delta S squared, when the interval is equal to 0. Okay, in that case, c delta t squared is equal to delta r squared. And here, in this case, the two events lie on the world line of a photon, in other words, on a light line. So these two events are separated exactly along the world line of a photon, and we call this, therefore, a light-like interval.